Okay, I think we know what's going to go on here, yes?
No.
Well, I've got it hooked to water, and the water is going to, what's it going to do? Who wants to explain this demonstration? Natalie's explaining. She's like,
Oh.
yeah, it's going to go back in the sink, and we think it's going to follow this path. Okay, so when I made this, all I did was I put these every 10 centimeters, right? And then I made the length of it a parabola. So whatever it was, I just did something squared, made a spreadsheet, and there it was. So this is describing a parabola, and the water, by the way, is squirting out on this side, and those things are on that side, so they shouldn't hit each other. We should be good here. But it's tricky, because when I turn this on, I want to turn it off. If I turn it on too hard, it hits me, and then if I turn it on too slowly, it goes all over the counter. So if I'm really good, I turn it on, and it just goes right into the... Okay, so we'll see how good I am. Now, I don't want you guys to underestimate how hard this is, okay? Because this faucet is communist and wrong. It's a bad faucet. To turn it on, I turn it to the right, which I believe is wrong. All faucets should turn off to the right and turn on to the left, but this one's backwards. I'm pretty sure. So let's just try it. This is the low risk situation. Okay, here we go. Okay, here goes the water. And what you do is you get to right there, and you let all those bubbles kind of go. Okay, are we ready for this? See how good I am. Ooh, not bad. And then if I adjust this, oh, come on, stop that. If I adjust that just right, it follows that path, and we should applaud, don't you think? It's like, yay, it's a parabola! Woo! And wouldn't that be boring if that's all the demonstration did? Yeah, I know. Okay. Now, the best way to think about this is, if you look at this, it's, the water's going out. What? Oh, you guys! Oh, come on! No, okay. There's two ways. I can't believe you thought that. Okay, there are two ways to think about this, okay? Way number one is using the stuff I taught you, which is 1FAT squared, and it's Rene Descartes, and it's people flushing toilets like crazy, okay? But here's the idea. The water leaves this thing with a horizontal velocity, and so it's got this constant horizontal velocity. It reaches here at a certain time, here at a certain time, and it's just like clockwork. We could set up a metronome, and it would go here, 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 here. It would just go right across, only a lot faster than that, yes? Okay? But vertically, the velocity is not constant, and so in successive increments, it's going faster and faster, so it goes farther and farther, and that's why it follows a parabola. It's going farther in the vertical direction than it goes horizontally, yes? And that's why because the vertical is 1FAT squared, that's why it's a parabola. Okay? Now, let's not use Descartes. Okay, let's use Einstein. Are we ready for this? Yes, okay. And that's how you say it in German. It's the actual pronunciation. Okay? So, what Einstein would say is this. If we were to turn gravity off, what would the water do? It would go in a straight line. It would follow the shadow of the ruler, would fly across, it would hit the screen, it would bounce off the screen, it would float in midair, these undulating blobs. They would eventually get sucked into the air intakes of the computers, and the computers would explode with like Hollywood sparks, wouldn't they? Are you picturing this? Yes. Okay. Now, with gravity, because there's gravity, the water is falling off of that trajectory by greater and greater amounts every interval of time that passes. Okay? Now, are we ready for this? This is the part that, not that part. Okay? This is the part that blew my mind when I was a student. What happens if I tilt this? A little applause, please! Yes! Thank you very much. Okay. Why does it still work? Well, because without gravity it would follow Well, it would now be going up. It would follow the shadow of the ruler, yes. But because there's gravity, it falls straight off that path, straight down, yes. The same amount. Off that path, the same amount, which is really pretty cool. Now, I know that there are people in this room that could calculate exactly where that projectile is going to be, you know, given this velocity and given this interval in time and all that stuff, right? But that's a very elegant explanation, isn't it? I think we need to give Einstein a little applause there. Here we go, right? How about if I tip it down? Let's make it level again. Stop. It never stops doing that if it ever hits the thing, right? And then I can tip it down, and indeed. Indeed, it still works. And then let's tip it back this way. And now when I turn it off, there's a strategy to turning it off. What is the strategy? Yeah, you turn it off immediately, right? You don't like turn it off slowly. Okay, now remember, what kind of faucet is this? It's communist and it's wrong. Okay, and so to turn it off, I have to turn it briskly to the left. Now, my first year of teaching, I forgot that. I was standing here. It was the exact same setup, different classroom, same setup. Standing right here. I go to turn it off. And what did I do, really? Turned it on full tilt. Wow, that's like a really strong super soaker, right? So I turn the thing on all the way. And it's hitting me right here. I'm right here. I don't know why, right? Hitting me right in the face. Now you would, for your part, turn it off then, right? You turn it the other way. I, for my part, sat there for some period of time going, why am I so wet? Okay, here it goes. I think it's to the left. Thank you. All right.